Okay, so in today's video, we were talking about how to use the Labview to control the function generators. So a lot of the time, actually, we can generate functions of the arbitrary forms and control them with simple function generators. But one problem is sometimes you want to have the function generators that would have multiple channels. So one way of doing that is just go through this, like basically the PIX waveform generator. So basically it's a modular design. You can put many modules in there, for example, over here. So there are many modules, like you're just putting them slide into the computers, and they can do it. But the problem is, like you can see, the price goes like much higher as you go more and more advanced things. So for example, this is 2 channels, like wow, over like tens of thousands of dollars. One way of doing that, we can find very cheap function generators. For example, on Taobao, we can find over here. So we can have this kind of function generators, cost like $800, or have some kind of this kind of function generators, even simpler. Okay, even simpler, and it's something like this, like $500, and you can get a very nice platform. But actually, there is really nothing inside. So it's although it's have a big case, but I think its inside is extremely simple, and of course the cost is very low. One problem for that is you can get this function generators, and they have a USB port on the back, but there is no Labview program provided on the internet. And I searched online, there is actually not many informations, and people are asking how to do this, and in the forum, and there is no much result out of this. But nevertheless, let's see what you can do. So basically, if you go to their website, okay, so the website from the companies, what you can see is actually you can download a bunch of things. Okay, for example, in the PC softwares, they actually have this kind of serious communication protocols. Okay, it's actually listed. What kind of protocols they are actually using, but it's a little bit more intriguing to read, or difficult to read. It takes me some time to actually figure it out. So I'm going to share you how to actually do that. Once you figure it out, it's actually pretty simple. All right, so let's get started. So like as examples, because basically these two things are pretty much identical. One is have a smaller factors, okay, form factors. Another is bigger. Actually, this one is even cheaper. So I will use this modules, like it's FY6900. Okay, so 6900, and it's as example of doing that. So basically, have a USB port on the back. So like what you do is just connect this USB port to this, and then they're going to automatically connect. And they're actually using a very simple USB to a serious port converter inside. So once you plug it in, so you can start to see on the computer. But like the next thing is how we actually could program the things with this. All right. So in order to get started, the first thing you definitely need this files, basically the communication protocol specifications. So today I'm going to use this one. So specifically this one. So this is a 6900, so it's actually this one, this guy. Okay, FY6900. Okay, so let's get started. Okay, so before I actually started, like I would like to plug this in. Okay, it's actually plug it, and it's actually powered by the USB port directly. So let's have some kind of VIs coming in. So in order to start this, so this is once you start it in, this is actually, as I said, it's a serious port. So it will be extremely simple. You just go to the instrument, okay, Visa, and you could open a Visa, okay, and it says, okay, create a constant. Oh, sorry, not create a constant. Create a control. Okay, so it basically has control where this is actually coming in, and then. Well, we want to read a little bit from here. Okay, it says actually this one using 115,200 baud rate. So again, so basically it wants to create you want to change the baud rate a little bit, so just go to the series board configurations and go here, change for this. So if you're using this a little bit older modules like FY6300, actually they're using the very standard 9600 baud rate, so you don't need this configuration anyway. Create a constant. Okay, so we want to change this one to 115200. And one thing is actually in the control flow. They actually needs to change the control flow constant, okay, into X on, X off mode. Okay, this is actually also required by the machine itself. Okay, so the next thing is we can start to create a visa right. Okay, visa right. And all the command is actually listed. Okay, so all the command is actually listed here. So they actually have a two kind of set because each format have a two channels. Okay, it's basically output 1 and output 2. And these two things is actually using different code. For example, this is a main wave is a WMW. And if you this okay, second wave, okay, it's actually using a WFW, okay, but like it's actually all listed over here. Extremely simple. So so what we need to do is let's say we want to create some kind of control, right? So we want to control what kind of waveform they actually come in. So what we can do is create some kind of string constant. Okay, let's say this is WFW, right? So let's just go here. I'm sorry. So it's WMW. So WMW is the first channel, and the second channel is WFW. Right? So there are actually two channels. But basically, we need to select this. So in order to actually do it a little bit better, so what I want to do is I want to create some kind of case, and I want to do this here. So I want to create some kind of menus so we can select from this. So in order to do that, just go here. And what we can do is enumerate. So in this way, I says, okay, waveform, okay, something like that. And in waveforms, just here and it says, okay, it says edit item, because it could have different kind of values you can put it in. So in this case, the WW, so there are different kind of waveform you can actually come in. If this is a 0, it's actually a sine wave. Okay, if this is 0, basically it's because sine wave. So basically, like I'm just going to create several, okay, pretty commonly used one. So like there is a sine wave, and if this is 1, should be square. Okay, if it's 2, should be rectangle. If it's 3, should be this one. 4, CMOS. Okay, 5. One. Oops. And there have a DC. Okay, so you can keep adding, and they actually have a more. Okay, there are over 30 some. There have arbitrary forms you can actually put it in. Like I just show you how to do this, and you can do it by yourself. Click OK. So by doing that, you can see there is a menu so you can select, and each actually represented is one specific numbers. All right, specific numbers. And at the back over here, so let me make it as an icon so it's smaller. So I want to convert this guy into a string. Okay, into a string. So it's basically a number to decimal string. Okay, So this decimal string is coming in, and we have a two kind of waveforms. So one is a channel 1 or output 1. Another is channel 2. So in order to do that, again, I'm going to create another. It's called output. Okay, and in here, I could have let's say this is called output 1. And this is output 2. I'm sorry, just do this one. This is easier. So don't get confused. But when they actually select output 1, they actually have a case is 0. Okay, so this is fine. So we can start to select this guy. Okay, and then let's go to the back. Okay, as icons. Okay, so we want to use this to actually select a case, right? So select which kind of a command, because if it's output 1, we want to use in this command. If it's output 2, we want to use this command, right? So in this case, we actually create a case. Okay, create a case structure. So in the case, we put it in here, and we can output this guy here. So that means that if it's output 2, we choose, let's see, okay, so what is the command here? If this is output 2, output 1 is WMW, okay, WMW, so WFW is output 2, WFW is output 1, okay. Okay, we can make this a little bit smaller, so it's easier to see. Okay, so they're actually coming out or from here. Okay, that's fine. This is good. And with this waveforms and this waveforms and since we can actually using a string to actually make command lines. Basically, this is whatever the command is actually coming in, but at the end, they said you have to using end of the line. Each command is marked with end to new lines, so you have a end to line decimals marks over here. End to lines marks. So that is so basically it's here. So in this end of the line command, okay, end of the line signs, and let's remove this a little bit. So just go here. So this is going to be the command we want to use. Okay, send it in. Okay, and we can goes here, move this a little bit down here, and this command needs to be set it in right here. Okay, and sometimes I want to, okay, a lot of time, as I said, it's easier to have a subVIs, because this one we can use it many times. So I could select everything here. I would say edit. Okay, I would say create a subVI, and then they're going to create a small stuff over here. Okay, and the output the waveforms is here still. So I could wire it a little bit down here, so it will be easier for everybody to see. Okay, and one thing actually I want to further edit, because in this subVIs there is really nothing, but down here there is no output. So right, actually, like I want the visa actually output, and the arrow is also output. So in order to do that, actually I have a visa. So just go to the back. Okay, we want to create a control indicator. Sorry, create an indicator, and this guy we want to create an indicator as well. So this is called the visa out. So this is a visa out, and this is actually the this is called the visa in. This is actually the visa out. Okay, so we have the output to select, and which is two forms, and have a different kind of forms over here. So that is it, and we can save this guys, and let's say, okay, save it as a waveform. Okay, I just replace it. Actually, I already did it once. There is actually a link. I need to link this one to visa out. I want to link this guy to the error out, and we say save, and now you can see there is two output lines over here. Okay, so next thing I want to do very similar stuff. I would okay, goes here. I pretty much would copy. Okay, I will copy these. Okay, I will copy these down here. I will do one more time of what I just did. Okay, connect it here, and then this time I want to create, let's say just examples, I want to create a phase difference. Okay, so I want to do is basically set the frequency or set the phase. Let's say just I want to set the phase. So in order to set the phase, it's going to be set the phase of the main wave is a WMP. If this is a WFP, that means it's a second the output 2, right? So that is fine. So WMF or versus WMP, right? So P, okay, here, and so for this guy, actually, I just don't need it. Okay. B, and I put output. For this one, I just create a constant. So I know this is output 1. Okay, and similarly, I have this guy. So I have the output 1 or output 2. Okay, create a constant. This is output 1, and this is actually coming in. And then I have a phase. So for the phase, what I can do is I can create a dial. Okay, I would say, okay, this is phase. Okay, and let's have values from 0 to 360s. So once I start to move, actually it's going to change the phase delay between two different phases, right? Can do is change this guys, okay, into a integers. This is integers, because if it's not integers, it's going to be have some problems. Okay, it's going to be difficult to do. Okay, I'm just doing this for simplicities. It'll be simple. Visa out, and then I'm going to create visa panels, and I'm going to close this guy. Okay, close this guy. And for this one, I also want to make a subVI. Okay, I want to make a subVI. It's just select this one and create subVI. And this will be fine. Okay, and in the subVIs, you have in and out, and everything is just there. And we say, okay, visa out, and this is a visa in, and it's already linked everything. So I could save this one. I say this one is called the phase. I already could create one, but like just this is already fixed, so it's actually here. So once you start to run this program, it's going to change the phase as it needed. All right, so in order to actually continuously changing this, I could do is create a while loop. In this while loop, there is a stop, and I could just go here and change the ESC. Because sometimes I could click this stop, and what else I want to do is using the the keyboard to change this. So the keyboard is here. So basically, I press the escape. That means it's equivalent to stop. All right. Okay. So that'll be fine. And let's go here, and we can select the account 4, which is the account we are actually on. And now let's see. Okay, so let's take a look when we actually press run. Okay, when we actually press run, they actually change the one to the square waves, and we can change the phase just as we already did. But one thing actually you can see is actually the screen is flashing. It's actually flashing because actually every time I actually running this program, they actually try to send a new phase in there, which interrupted the whole operation of the machine. So what we actually want to do is basically, if we don't change, we don't want to make the command coming in. And also, like, I could press the ESC, so that means it's going to stop. All right. So the next thing I want to teach or event structure. So it's actually in here. So I want to do is, okay, so don't run this program unless actually I change the phase or change the output, right? So unless I actually do something, otherwise I don't change I do not run this while loop. So this is actually in here. So this is in programming, there is a structure. It's called event structure. Okay. So it goes event structures, and okay, so like this ESC should goes here. So goes, so whatever the material, the thing is actually in there. So all the necessary properties, you just press here. So this is an event structure. So in the event structures, okay, you press here, and it says edit event handle by this case. Okay, so there are a bunch of things here. So let's say, okay, phase. Okay, so what happens in the phase? So if the phase value changed, it's going to run. Okay, it's going to run one thing. Okay, phase changed. It's going to run, and we can okay. And also, I could do add an event case. Okay. So that means for the control is the ESC. Once the ESC is changed, so basically I press it, it's going to change as well. It's going to run it as well. So it goes here. So the case ESC value changed should be here. So that means I need to move the ESC keys in this case. Okay. I click here. Okay, so there is something like that. It's not on it, so that's fine. Okay, so now we can rerun. So what is this one? Okay, so this is we can rerun this program again. So in this case, actually, I would change into the sine wave. Now let's take a look of what's going on when actually I press run. So firstly, I actually change the sine wave, and everything looks smooth. It's not doing anything unless I change the values, because I could still change the values of the phase. Whenever I change this, so the phase change correspondingly. It's very responsive as well. It doesn't send the command in as I do not change the value of the phase. Okay, so it's only necessarily it's going to run. So this thing is it both save the computer time resources and make sure I'm controlling it whenever it's necessary. It can be very responsive. Okay, so this is all I want to show you today. Hopefully it's going to be helpful for your research.